Bresenham's line drawing algorithm. First we discuss when the slope of the line is less than 1. We know in a raster system the monitor consists of the pixels. When a line to be drawn, we have to select the proper pixels and plot them to get the smooth line. Now in this algorithm, if a previous pixel is already been selected, then what will be the next pixel to be selected will be determined by these algorithms. Now let us consider a pixel xk and yk already been selected. And then what will be the next pixels? Already I told that we are first considering the slope of the line is less than 1. In that case, the x coordinate will be sampled at unit step. Then therefore, here you can see we have considered the next pixel, we have considered the xk plus 1. And there are two possibilities here. One is the yk, another is yk plus 1. And which is the near to the line, that pixel would be selected. Now, you see here I am repeating the same thing again. The case 1 where this slope of the line is less than 1, and in that case x will be sampled at unit interval, already I told. Now another case to be considered. Now the starting point and the ending point. Now we are considering the ending point x coordinate is greater, and in the similarly the y coordinates ending point is also greater. Obviously in that case that x also to be incremented and y also to be incremented, so that because the starting coordinate is less and we have to reach the higher coordinates, therefore it has to be incremented. Now we see the derivations of regarding these algorithms. We know that as equation of the straight line is y equal to mx plus b. Now because already I told we are considering m is less than 1, therefore sampling rate will be plus incremented, because where the initial point is lesser than the ending point. Therefore x coordinate will be incremented, and if you substitute here we'll get this equation. Now as we shown in the diagram, d lower is equal to y minus yk, and we'll get this equation, and d upper will get this equation, and difference between the d lower and d upper. And already again I show you what I am referring to d lower and d upper. Therefore this is the upper pixels distance is I am referring to the d upper, and the d lower already, and therefore this is the equation for d lower, and this is the equation for the d upper, and if the difference is this. Now in this algorithm we have to find a decision parameters, and decision parameter is the difference between the d lower and d upper, and it will be multiplied by the delta x, and delta x is the modulus of the difference of the x coordinate of the end coordinate and the initial coordinate, and as similarly what is delta y. Now if we substitute that in the previous equations, then we'll get a equation for pk, that is the decision parameters, and here I am showing the derivations of it. And next you can see if the lower pixel is at a lower distance from the line, therefore in that case pk will become negative. From the equation you can see the pk will become negative. Therefore if the pk is negative, the lower pixel to be selected, otherwise the upper pixel will be selected. Now the in the earlier equations, the what we got the pk, we are replacing the pk plus 1. That means the next decision parameter, and we got this, just we replaced k by k plus 1, we got these equations, and thus subtracting from one another, we got these equations. And then already I told we are sampling the x coordinate at a unit step, and because a unit step, that is we are incrementing by 1, because as already I told, because the ending coordinate is higher than the starting coordinate, therefore we have to increment, and therefore we are incrementing by 1, and therefore we get this equation for pk plus 1. And in case of a yk plus 1, there are either yk plus 1 will be yk or yk plus 1. Therefore these terms, either it may be 0 when pk is less than 0, and or it will be 1 when pk is equal or greater than 0. Now that I am again I am here, I have written here that pk, if pk is less than 0, then yk plus 1 is equal to yk, and this will be the pk plus 1. This is the next decision parameter will be this. Otherwise this will be the next yk coordinate will be this, and therefore the decision parameter will be this. Now we are coming to the that to find the initial decision parameter, how to find out. Here therefore we have gone back to the equation number 6, and then we are substituting the value of b by, you can see the initial, because initial point lies on the line, therefore we can replace, we can substitute, and we get the b, and after substituting getting the b, and m is replaced by delta y by delta x, we get the, by these simplifications, we get the initial decision parameter as these equations. Now we'll summarize different possibilities of Bresenham's line drawing algorithm. First we'll take the case of slope is less than 1, and that ending coordinate of x is greater than the starting coordinate. Here you can see, and exactly similar for a y coordinate also. Now in this case, we take the 2 point, one is the starting coordinate of the line and the ending coordinate of the line, two ends, extreme end of the line, and then first we plot the initial coordinate, the starting coordinate, and then we calculate this. Already I stated what is the meaning of delta x, delta y, and this is the initial decision parameters. Then after that, if the pk we found to be less than 0, then the next pixel will be, x will be incremented by 1, compulsorily it will be incremented, but y will not be any change. Y will be remain the same as the previous pixels, and the decision parameter will be these equations, pk plus 2 delta y. Otherwise that x coordinate also will be incremented by y, and the y coordinate also incremented by y, and this step will be repeated for delta x minus 1 time. And this is the summary of these algorithms. Now another case, when m is less than 1, but the initial x coordinate is greater than the ending x coordinate, and exactly similar in the case of a y. That means it is from a higher coordinate, it is coming to a lower coordinate. In that case, that first we get these 2 points, and first we plot this initial coordinate, and as in the previous case, the formula will completely remain the same, and only difference is that x in this case x coordinate, because it is coming from a higher coordinate to a lower coordinate, therefore every step x will be decremented by 1. And if pk is less than 0, the y coordinate will be unaffected. It will take the previous value of the pixels, and the next decision parameter it will remain also the same equations. If pk is not less than 0, then again both will be decremented. The x also will be decremented and y also will be decremented by 1, because both initial coordinate of x and y both are higher, and it has to reach to a lower level. Therefore both will be decremented by unit step, and the pk plus 1 equation as remain the same as before, and it will be repeated for as before delta x minus 1 time. Another condition I have, you can see, summarize the Bresenham algorithm when the slope of the line is greater than 1 and the x initial coordinate of x is less than, and also similarly less than the ending coordinate, and y coordinate also initial coordinate is less than the ending coordinates. Now in this case also we take this to end to extreme points of the line, and first we plot the first point. In this case the completely whatever we got in the earlier case, it will be x will be replaced by y and y will be replaced by x, and therefore we'll find this value. And you can see here initial decision parameter, the earlier formula was 2 delta y minus 2 delta x. Here delta y has been replaced by delta x, and delta x has been replaced by delta y. Therefore in a simplified way, the x, wherever x, it will be replaced by y, and wherever y, it will be replaced by x. And in this way we find that if it is less than pk, decision parameter is less than 0, and the x coordinate will remain the same, but y will be incremented by 1. And that is also there is a difference with the when m is less than 1, and here m is greater than 1. Therefore every step the y will be incremented by 1, and the x coordinate will depend on the decision parameter. And therefore here, because it is less than 0, therefore x k will be the same as the previous value, and if otherwise the both will be incremented by 1. And you can see the decision parameter, next decision parameter will be this, and this will be repeated for delta y minus 1 times. And exact similarly, therefore if the initial coordinate of x and initial coordinate of y is greater than the ending coordinate, then as in the previous I discussed, then it will be all the things remain the same, and only difference is that it will be decremented because the initial coordinate is higher. We have to reach to the lower coordinate, therefore therefore it will be only decremented. Therefore if it is pk is less than 0, therefore x coordinate will not be affected, and pk is this other, and if it is otherwise both will be decremented by 1, and this is the algorithm. Therefore I discussed here all possibilities of a slope, all possibility of slope, and this is all about the Bresenham's line drawing algorithm.